Alright, ladies and gentlemen, new to YouTube here, figured out this would be a good first video for me. It's a bit of a long one, so bear with me. What I have today is testing for the DiamondBack Nozzle, and compared to the Hardened nozzle and the nickel-coated copper nozzle amongst various different materials here. PETG, from Creality, Hyper PLA from Creality, and also a cheaper Red PLA standard. If you guys have ever been curious about the DiamondBack nozzle and how well it can improve your prints, stay tuned. I do have a couple other things in this video, such as the K1, couple of print improvements, as well as an extruder change. So feel free to skip those if you'd like. Results are towards the end. Thank you much for watching, and I hope you enjoy. Alright, so what I got here today is the DiamondBack nozzle, straight from DiamondBack. What I have is the DiamondBack. Comes in this very nice aluminum or metal, not really sure, package here that you can see right through. As you've seen before, it is brass with the polycrystalline diamond tip. Can't really see that great with my video, but I'll add some pictures in here. It is laser etched with the serial number, which is pretty cool, and the nozzle size. And if you zoom in far enough on the one that you get, it will actually have a 4 in the actual diamond too, which is pretty cool, though extremely difficult to see. So my plans with this video today are going to be, for one, the installation of the DiamondBack nozzle, and we're also going to do some back-to-back tests with other two other types of volcano nozzles. One being the original one out of my Creality K1 Max, and I also got the fancy 8-pack from Creality, which is another OEM one that comes out of it, which is a bimetal. Was a very nice nozzle, probably 25 days of printing on it, and it was great. The other thing we're going to do is the zinc coated ones, or whatever coating it is, that Creality sells in their 8-pack. And then we're also going to test it right against one of the hardened nozzles, directly from Creality. I don't have any other nozzles to test with, so those are going to be the 3 to test with. What I plan on doing is I'm going to do some temp towers, because a lot of people say the DiamondBack is able to run a little cooler, so we're going to be able to see the straining difference and the flow difference between the options here, and see how much or whatnot that it affects the straining and flow. And then we'll also adjust some temperatures, and instead of all the same, and rerun some tests and see how that goes. And see if we can optimize this thing a little bit for a little bit better printing, hopefully smoother. And I'm also going to run all these tests with PETG and also PLA, because everyone knows they behave very differently. And especially with the nozzle, the hardened nozzle, grabbing onto that filament and causing blobs, where this DiamondBack nozzle here is supposed to alleviate a lot of that issue and resist a lot of the cleaning, and see how well it improves some prints, and see if it is worth the $94.99 that it is currently on DiamondBack's website and Amazon. The other thing we're going to do today is switch out the K1 Max extruder, because as I ordered the DiamondBack nozzle, the day before that I was actually supposed to receive this thing, I started actually finally having some extruder issues with the K1 Max. I have had very good luck with the machine so far. only had one nozzle issue early on when I got the machine. But now I have roughly 44, 45 days of print time on the machine, which is roughly right around 1,000 hours. I did have some filament clog up and fill in the gears, and it looks like it stripped out one of the gears or something like that. I was able to get it cleaned out and functionable. I have ran 4 or 5 more prints through without an issue, but it's gonna give me issues, so I decided to order a new one from Creality. Pretty cheap, only about $30 roughly to do this. Very, very easy to swap out, but I'm going to show you how to do that anyway. Means I'll already be in the print head to change the nozzle, and it's all in the same area, so we'll just do that while we're at it. The other thing I'm going to show you is a neat little trick on the K1 to free up the axis a little bit by removing a couple springs that are in the print head to give you smoother prints, and actually helps a ton with the harmonics and the VFAs that the K1 is pretty riddled with. I did root my printer and input shaped correctly. It did help a lot, but there were still some that we could not fix with that. So after I did the spring removal, they cleared up about equally more by doing proper input shaping to this, so it is quite fine. Alright, so what we're going to do here real quick is we're just going to open the package up and see what actually Creality includes in their extruder kit here. There's a little slot in the back, so you don't have to go crazy on cutting it open and all sorts of stuff. So we got the extruder, which is in multiple pieces here. There is the new gasket or spacer isolator thing that they include there. And it actually does come with 2 new screws in case you strip out your originals or have issues. And that is it in the package. So what you get here is this is the final rendition of their extruder with the white top here. And of course these are metal gears. I know there's some issues with the K1C. These are the same gears that you get in the K1C. It is all metal, somewhat. The drive gears themselves are plastic, as most are, but where the filament runs is all metal. It clamps quite well. Never really had much of an issue. I've ran TPU, PLA, PETG, all sorts of stuff. Not a whole lot of issue. I don't really run a whole lot of carbon fiber. I plan to in the future, so this will be nice. As my original one, I never saw any issue with wear in the grooves here, and I'll show you that when we get the old one out. What I did have issues with, it was actually during basically a reload. I must have missed a little bit, and I actually ended up shoving filament into the little plastic gears here somehow. Don't ask me how I managed that. Completely my fault. But anyway, I ended up forcing a little bit on the backside of the extruder motor with the screwdriver, trying to make it work. Obviously, I now have a new extruder. And I'll show you the damage that I caused on it, so that you don't end up causing that in the future. Alright, so here we go. Here's the back side of the hot end on the Creality K1 Max. To change the extruder, it's actually made pretty simple. For one, I still have filament in here, so I do have it preheated right now up to 230 degrees to make it easy to remove. Pretty simple. I'm just going to unlock the extruder head, push down on the blade here, and pull up the tube. And the filament should come right out. We're going to tuck that off to the side over here for now. I do have the motors off right now on the printer. Should go ahead and actually just turn the thing off. Gonna drop the temp back to 0 now. So first thing we're going to do is this little black cover on the top. It's a pretty simple piece. It just pops right off. There's nothing exciting or anything like that holding that on. Just a couple nubs and it snaps on. I'm going to put that off to the side here. The next thing we're going to do is actually remove the extruder itself. So what we got is right here on the, looking at the machine, the right side. For you guys will be the left. We have 2 screws on this side and only 1 on this side. So we have a proper size hex tool here, and we're going to go ahead and loosen these things up. They are pretty small, so just be careful not to lose them. It's not very helpful when I'm working with black screws on a black plate. It makes it very easy to misplace and have to find them. So after you have those 3 screws out, it's pretty straightforward. You don't actually have to unplug anything or anything like that to be able to do this. You pull it up and then slide it back, because there is this short little PTFE tube here, and then there is going to be 2 more screws there and there. So this should be the same exact size to go ahead and pull those 2 screws out. I have to be very careful here. There is a bearing in here that sometimes will fall out. The new extruder does come with that bearing. So just give this a little bit of a twist here, and it should come off. A little snug. Sometimes if you move this gear a little bit, it does make it easier to remove. So, and that is off. So, to go back on, all you're going to do is take your new gasket, put that on there like so, and just like the opposite of removal, make sure you orient the lock the correct direction here. I'm going to place that down. This one should fall right into place, and notice how the bearing is on this assembly already and not stuck in the extruder head. So now we're going to go ahead and line that up carefully, and then it means I included it. We're just going to go ahead and reuse or use the 2 new screws that came with the new extruder instead of reusing the old ones. The old ones were fine in mine removing them, but I'll just have them for spares down the road. So pretty simple. It's just going to be the reverse of assembly or disassembly. Tighten it down. It is a plastic housing, so don't be too aggressive with it. It doesn't really need a whole lot. That's it, and you can just go ahead and make sure your lock and unlock functions. It's actually a lot stiffer than my original one was, which is nice. The other thing to remember, because I have seen people forget, is the new extruder does not come with this new tube. You can either cut a small piece off or just pull it out of your old one and install it into the new one. Just install it the same way, and then go back up and line that tube up, and then it should just drop straight down into place. Give it a little wiggle, and it should fall back down and line up. Now, assuming you didn't lose any of the screws here, you should be able to line these 3 holes back up, and always remember, just start all 3 of them before you tighten any of them up. That way, if there's any misalignment, you're not messing around and having to loosen them back up to realign something that wasn't lined up. That way, if there's any misalignment, you can just give it a little wiggle to get that extra little clearance that you need. I'm not going to swap in the new head or the new DiamondBack nozzle quite yet, because I am going to run those tests on the nozzle that I currently have in the machine. I've only done about 10 or so prints on it, so
will still give you a good idea as far as comparing new nozzles to new nozzles. That way we don't have any skewed results or anything like that. I have not printed anything abrasive or anything with the current nozzle, so we should have pretty nice results going forward onto our comparison test. So one thing to do while you're at it is just go ahead, go back into your extruder settings, bump your temperature back up, and once it's up to temp, just go ahead and reinstall. As always, clip off that little end. That way you're not fighting with it to get it lined up. Zips down here. Always give it a little bit of an angle. That way you're not fighting the blunt end tool. Unlock it, drop it in, drop it back in, and slide that back in just like normal. And now we'll run on to the stringing test. So we're going to start this test off with Red PLA in the color black. Figured it would be a good test to start off being a cheap filament, as not everyone runs expensive stuff like Polymaker, Hatchbox, etc. So give it a good test with the Red PLA first, then we'll move to a little bit more expensive PLA, or more quality high-speed PLA similar to, or probably run Creality's Hyper series. We'll also do both colors of those in black, and then I also do have a black Creality PETG that we'll be trying the string test on, just to keep all the colors the same. Alright, this first test is going to be with Creality's nickel-coated copper nozzle, I believe is what comes in the 8-pack. According to the website, it is copper with a nickel coating. So it is a pretty effective nozzle, and the nickel coating is very good at resisting hanging on to filament. My temp test is going to go from 230 to 180 degrees. So we'll speed this video up here a little bit and give you a little bit of time lapse. Alright, and that was the test of the nickel-coated copper nozzle. That one there. Kind of surprised, the 180 even finished out quite well. It is definitely very matte by the initial looks here, and I do not expect it to be very strong. But we're going to go ahead and leave this nozzle in here and do the flow test next. I have it set up currently to do 5 to 25 millimeters cubed. I don't fully expect it to make it all the way to 25. In the past, I think I've had it go to about 22, 23 with this red material, brand material. So we'll see how that works out. Alright, we're back after all the testing. I'm gonna cut the time lapses and videos a little short. Videos are already getting a little long, so I figured it was a good time to not bore you with that stuff and just move on to the results. I do have all of them laid out here. Starting off with the nickel-plated copper, PETG turned out pretty decent at 18.6 millimeters cubed, which performs quite well, about what I expected, as that's kind of what I've been using. The Red PLA turned out at around 21.6. So as you heard early in the video, that's about right where I've had these results before.
The Hyper PLA did perform a little bit better at 22.7, so pretty close to 23. Not a huge improvement over Red PLA, but again, that was only at 220 degrees. And if you're printing high speed, you're going to bump those temps up a little bit. Moving on to the Hardened nozzle, the Red PLA did okay at 13.7. The Hardened nozzles are known to not perform well at lower temps or at very high speeds at all. So as a hardened nozzle, that's about what the results should be. As far as the Hyper PLA with the hardened nozzle, it does absorb temperature better from no matter what nozzle you're using. I got it to turn out around 18.7 volumetric flow rate. So quite a vast improvement over the cheaper filament, and it does really show that that high speed filament does improve your flow rates, etc. Now, again, if you bump these temperatures up, which you're going to if you're using a strictly hardened steel nozzle, you will get slightly better results from this, and it will close that gap a little bit. As far as the PETG and the hardened, I did those tests at 245 degrees. I could not really get a good result out of PETG, so I just went ahead and admitted those because it doesn't really fall in line with the testing if I were to bump it up for the hardened nozzle. On to the Diamond nozzle. The PETG I got to perform at 16.5. Which oddly enough is actually a little bit lower than with the nickel-plated copper. Again, you would bump temps up and you're going to see these results even back out. But it was interesting to see at 220 for the PLA that the Diamond nozzle did actually perform slightly worse for PETG in my test. Now, if I were to change these tests and go to maybe even rerun it one more time, I might get slightly different results. Never really know with these tests, but it does kind of coincide with what I was expecting. Now, on to the PLA. The Hyper and the Red actually both performed at the 23 millimeters cubed. Again, the Diamond, transferring the heat better into the Red really took away most of the benefit the Hyper had over it. Both did print all the way to the top without a whole lot of issues. Where we had a little bit more issues with the copper nozzle with the Red. It did make the Red finish all the way out with minimal issues. So that is my results on the max flow rates. The Diamond, like I say, it did improve with the basic PLA. It held pretty much the same with the Hyper, and over the hardened, the Diamond performed extraordinarily well versus the normal hardened nozzle, which is really the comparative of the test here, because if you're buying a Diamond nozzle, you want it to replace your hardened nozzle. Because if you're buying a Diamond nozzle, you're generally going to be running abrasives, and we all know that it's not really designed to compete with the copper nozzles. It's designed to compete with the other hardened nozzles out there. Now on the next one, the temp tests. They were all pretty well as expected. The hardened nozzle struggled very hard with the PETG and the temp tower. The most that I could get it to print cleanly up to was about 235 degrees before the towers started breaking, which here I got 2 short towers, and here was the comparable test to how tall it should be, which is expected with the hardened nozzles. They obviously don't transfer heat near as fast or as well as the other options. I did get the both the Hyper and the Red PLA to finish out the temp towers. I did stop those right at 195 degrees because you're never really going to be printing that low, especially with a hardened nozzle. And I did carry that on to the other ones here. So on to the copper nozzle. We got all 3 towers to print out quite well. Stringing. I had some light stringing around 230 to 215. Cleaned out really good around 210 up to about 195. And then oddly enough, I did get some stringing back in there. And as far as the Hyper stopped doing the stringing closer to 220. So only 230 and 235 really had stringing. And then it did finish out, and I didn't really have any of the stringing at lower temps than 220. So pretty impressive. Qualities turned out well. I did have a little bit of under extrusion starting around 195. So that's kind of the limit of what we're doing here in the temp tower on Hyper. The Red, I did start showing some under extrusion around 205 and 210. So the Hyper definitely does flow better and work better at the same temperature. As far as the PETG on the copper nozzle, about 235 is where the stringing stopped. As with PETG, you're always going to have some stringing, etc. Very usable up to even 250, 255 with acceptable stringing. 260 did have a little bit excessive stringing. Now the diamond nozzle here, as far as the PETG goes, at 260, 255, and 250, I had excessive stringing, which does show quite well that diamond nozzle is transferring heat into the filament at a much faster rate because it's keeping that strands much hotter. Now 245 did have some stringing, but acceptable results. Completely gone by 240. It did print out all the way up to 220 with no stringing, though it's a little bit more matte finish, but significantly shinier than the copper nozzle. The equivalent sheen is probably around the 230 as far as the PETG goes. And PLA, Red and Hyper, both performed similar. Hyper, again, stringing just starting at 220, and same with the Red. They both performed extraordinarily well, clear down to 180 degrees. The Red PLA, a little bit of under extrusion, right around that 195, and I don't really have any signs of it except for maybe a little bit at 180 with the diamond, with the Hyper PLA. So test pretty much coincides with what we expect. I'm gonna go through here, do some breaks on these, and kind of see out maximum strengths. Alright, and here is the results after the break test. So the first row here I have PETG, Red PLA, Hyper PLA, and then hardened nozzle, copper plated nickel nozzle, and then the diamond nozzle. So with PETG, hardened nozzle, very, very weak. I didn't have any strength in it really up until about 250. 255 held great. With the copper nickel nozzle, we really didn't have strength until 240, 245. And then we were able to get strong at 240 with the diamond nozzle. So results pretty impressive. They do show that the temperature does matter quite a bit, and depending on what nozzle you have will change the strength of your parts. So next here is going to be the Red PLA Hardened. I did have to go to 215 to really have any strength. I was able to go clear down to 195 here with the copper-plated nickel, and then, or the nickel-plated copper, and then with the Red PLA, interestingly enough, was stronger than the Creality Hyper at even clear down to 185 degrees. This part has a lot of strength in it. So again, Diamond was able to improve the performance of the cheaper filament by quite a large margin. Now we go into the Hyper. A lot closer results. Hyper has been known to not be as strong, or high-speed filament has known to not be quite as strong as its counterparts. I was with the Hardened nozzle, 215, which coincides pretty close with the other one. With the nickel copper nozzle, got up to 190 here, so it was stronger with the nickel than it was with the Red PLA. So there is some strength there. And then same exact results, 195 with the Hyper Diamond. Now it did take an extreme amount of force to actually break this off. Almost could have countered it as a 185, but just because I did manage to break it, I'm going to call it 190. So there's the overall results. And to finish out the test here, I printed the benchy in the Diamond nozzle, and of course we had to give it a little bit of a diamond stand. It printed extremely well. Definitely one of my cleanest benchies that have ever come off of this machine. And believe it or not, this was done at full speed with PETG even. I did increase the temp up to about 250, 255. And as you can see, there is very, very light stringing through the windows and the doors, but this thing turned out extremely well. The top here printed out perfect. The windows there printed out extremely well. Lots of detail, and it turned out great. So figure that'd be a great first print for the Diamond nozzle, is a Diamond benchy. Anyway, if you liked the video, please like and subscribe so you can make some more of these. And if you have any other tests you would like me to do between any of the nozzles, etc., feel free to comment and let me know. Thanks.